of our camera input, and then we're able to threshold that image to say whether to go to the left or to the right of the object.
Yeah. What will be the applications? Why would you like to run a drone inside the game?
Mostly in places that are very hard to reach, so like tunnels.
Right.
Warehouse.
Maybe if there's a search and rescue within a building, like something was on fire. Another good one is inventory in a warehouse. So instead of having to go row by row in a warehouse, you could just have a drone go.
That's a camera footage, right?
Yes.
Then you'll be able to monitor.
Yes, to be able to do like counting of objects and so on. Yeah. Any other questions? Thank you.
Okay. Is this one like automated?
You guys, I know you're doing presentation, but if you don't get your lunches, there'll be no
Good.
lunch.
Good.
You're good?
Thank you.
Don't
We're
want
good,
it?
yeah, thank you.
Okay. So is this like let's say you want to move to point A to point B? You can set it up and it's going to move it for you, like all your control.
Right now, this is a semi-autonomous solution.
Okay.
So we have to use the transmitter to make it go forward. The autonomous part is its ability to make corrections.
Okay.
So if you're in the way, it would be able to divert for a brief moment before going back to radio control. We do plan in the future to make a fully autonomous solution. However, due to time constraints, we're working with the semi-autonomous solution.
So basically, you control this one by a control or something, and when it detects some obstacle, it's gonna adjust and move. Okay. So when the obstacle happens, it's not gonna listen to you. Like what happens? Like let's say you're moving that, and if something happened, so it's gonna start.
You are correct. We worked in a very controlled environment. So, I mean, we tried our best to eliminate any room for error, but in a real life scenario, if there were a lot of moving objects, it would be hard to do this. So more future work needs to be done.
Okay. So for this one to implement, like, did you do any coding or something?
Yeah, so that's the flight control algorithm. It is all done in C++. Essentially, if you want to fly, you need to be able to control the desired rotational rate and angles. And so to do that, we have our sensors, which provide a feedback on the error. So if your transmitter said that we wanted to be a certain angle, your sensors were telling you otherwise, you would subtract that error to our controllers and we'd adjust. The way we adjust is the processor sends PWM signals to the ESC, electronic speed controller, which controls the speed output of the motors. So if we did need to make a correction, it would lower the power to some motors and increase the power to others to correct its rotational rate or angle.
Okay. So when you do this, like, you can do this outside, or like, is there a legal problem with that?
At the moment, we've just been testing indoors, but with a drone of this size, you have to get certain licensing and follow certain regulations. So in the future, as we progress with this work, we'll have to follow these guidelines.
Okay. So for this one, like, no coding or anything required, or what?
Oh yes, the flight controller was all programmed by ourselves.
Okay. Is it like which language is that?
C++.
C++, and did you use any applications to implement?
We use the Arduino editor.
Arduino, okay.
The STM32 processor, it's unlike an Arduino, where an Arduino uses a MBR architecture. We're using an ARM-based architecture.
Okay.
However, both can be programmed using the same code base, C++ Arduino editor.
Okay. Thank you so much. You have any questions?